this page, right? Okay, so this is where we're at solving rational equations. So everybody has one. What does it mean by solve?
Solve for the variable.
Solve for the variable, okay? It means we want to find out the value or the values that will make this equation true, right? What number, or it could be numbers that will make the equation balanced. So when we look at this, example 1, 3 over x equals to x minus 7 over 6. First thing that we're going to do is let's start with stating the non-permissible values. So what are the non-permissible values?
0.
0. And how do you know it's 0?
Because x is in the denominator.
Okay. What makes a value not allowed? Because it will make the denominator 0. In a rational function, rational equation, you cannot have the denominator equal to 0. So this one here is the denominator, is x. So I'm just going to put NPV, x cannot equal to 0. What about this one? Any non-permissible value here? Nothing, right? Because the denominator will always be 6. It will never be 0. So if you look at that one, here's the thing, because I know some of you were probably thinking, I'm going to cross multiply this. Cross multiplication works if you have numerator divided by denominator equals to the numerator divided by denominator. It's not always the case that way. We have to get rid of the denominator by first multiply with the lowest common denominator. Lowest common denominator. So what's the LCD in this case? 6x, okay? Is everybody okay with that 6x? Yeah, it's okay to proceed. So what we're gonna do is we're gonna multiply each side of the equation by 6x so that we can get rid of the denominator, okay? So 3 over x equals x minus 7 over 6. Okay, so I just basically rewrote the equation all over again, but I'm going to multiply. I'm just going to use the square brackets, doesn't matter. Multiply each side by 6x. Okay, so what I did on one side, I did it on the other side.
So why is that LCD 6x together and not separate?
It's 6 times x instead of x plus 6.
Even though they're on separate sides of the equation.
Okay. What I could probably do, I'll finish this off and then I'll get back to your question. Okay. So, or maybe down the road it will make sense. Fine. So here, what happened is, if we multiply this into this fraction here, what can we simplify it? The x will cancel there, right? That's a common factor. X divided by x, they cancel each other out. And then what's left over? 6 times 3, which is 18. So we just write down 18. Okay. Next, on the other side, if we multiply x over x minus 7 divided by 6 by 6x, can we cancel something? The 6 will eventually cancel. The 6 cancels. And what do we have left? Okay, so some people are already saying x squared minus 7x, right? And that came to be because you have x minus 7 times x, right? So you're going to multiply this in there. So I'm just going to go like this. So whoever is watching this video later on, or if you're watching this video later on, you know what's going on. So this cancels, so you're left with x minus 7 and then the x. Multiply it in. So 18 is equals to x squared minus 7x. Okay, now we're going to end up with a quadratic equation. Notice that? It's a quadratic equation. So how do we deal with a quadratic equation? Okay, so what we can do that by factoring or completing the square. That's my least favorite one. Or, okay, you're just stating all of the options, right? So factoring or quadratic formula, okay? So here we go. I'm going to bring this to the other side. So it becomes 0 equals to x squared minus 7x minus 18. Okay. And then we look at that one. Okay, can I factor that piece? I'm going to go over here. Yeah, it's factorable, is it? Okay, it becomes x minus 9x plus 2. Okay, so that gives us what? What are the x values that will make this 0? X is equals to 9. X equals to negative 2. Now, it looks like we got two solutions in here. Two solutions. Okay. Any of these non-permissible value? No, right? No. Because our non-permissible value is 0. But this is 9. This is negative 2. So therefore, the solutions, there are two of them, are x equals to 9 and x equals to negative 2. Okay. So that piece. Okay, that's a good question. Should I verify? You know what? Let's see if we can verify this with our mind. So 3, if you do 9, then it would be 3 over 9, which is 1/3. And then if this is 9, you're going to get 2 over 6, which is also 1/3. Okay, so that one works. And then, yeah, you can verify the negative 2. Okay, is that good? Some of these answer might be a non-permissible value, so that means a no-no. You don't want that one. It's not automatically not a solution. So looking at that, you got two solutions. Do you remember us talking about how to figure out the solution by graphing? So the roots of the equation is the same thing as the x-intercept or the 0 of the function. But if you graph this separately, it will be the point of intersection, right? Was that what you were going to say, Amber? Okay. So, okay. Over here is the solution for that, okay? What are we solving for? X, right? We're solving for x. So this graph here is y equals to 3 over x. And then this straight line over here, that's the y equals to x minus 7 over 6. Since we did this in two separate graphs, it's a point of intersection. So what is the solution? The solution are the x values, right? This one says 9 and 1/3. Well, the x is 9. And there's actually one more over here that I totally did not plot. What could this, any guess what that would be? Negative 2. So that's x equals to negative 2. Okay? And if you want a specific coordinate of that, that's going to be negative 2, comma, negative 3 halves. But we want just the x, so it's negative 2. Is that okay?
Why does it look like it's at 1.5?
Yeah, negative 1.5. So negative,
Oh,
this is negative
negative. Oh,
one
this
and a
one.
half. Yeah, right there. Yeah. Is that good? It gets very complicated. As you can see, we've graphed some of rational functions, and it can get really weird. It can get complex. So there has to be another way of solving rational function. Well, one of which is solving it by algebraic solution. Okay? Good? Let's try example 2. Okay. Yeah, for sure. Yeah.
The question is quadrant, right? The question is quadrant. So how that should be like a quadrant? X is given as 7 times 18.
Oh, okay. So you're saying it boils down to a quadratic. Okay. Okay. Now you're looking at this final step after we've canceled a whole bunch of stuff already, right? So what I'm gonna do later is we'll take a look at decimals later and then see what that one would look like. Okay. Any other questions? You good? Okay. Good. Here, let's take a look at example 2. What's the NPV? X cannot equal to 0 and x cannot equal to negative 1. Is everybody okay with this? Right? Because if x is 0, this whole thing will fall apart. If x is negative 1, this whole thing will fall apart. You cannot have that. Okay, good. So what we're going to do is get rid of the denominator by figuring out the LCD multiplying by lowest common denominator. What's the lowest common denominator? Okay, so 2x times x plus 1. Okay, 2x times x plus 1. So you look at this one. What are the factors in here that I see? I see a 2, so I put a 2. I see an x, put an x. I see an x plus 1, so x plus 1. Okay. So what happens if we multiply each side of the equation by the lowest common denominator? Let's see. So this is going to be 3 over 2x minus 2x over x plus 1 equals to negative 2. Okay, so far so good. So multiply each side by LCD. So this 2x times x plus 1, we multiply it in. Okay, let's cover that piece. If we multiply these by this one, anything cancels? The 2x in the denominator, this will cancel that one, right? What's left? X plus 1 times 3. Okay, so let's write that down. 3 times x plus 1. Okay, good. Now if I multiply this, there's a name for this. It's called a distributive property of multiplication. So if I multiply 2x times x plus 1 with everything here, Anything cancels? X plus 1 cancels. I'm going to cover it with my finger. We'll cancel with a x plus 1 there. So what's left over?
4x.
Okay, basically the 2x and the 2x. Okay, I know you're like wanting to just get this done and over with. Okay, but I like to show. See, that's why I'm a slow processor. I like to show everything. Okay, good. Okay, now if I multiply all of these with this, anything cancels? Nothing cancels, right? Because there's nothing in the denominator. So that really becomes this times all that. So I'm just going to go negative 4x times 2x plus 1. Just multiply these so I can easily multiply it in. So, hey, great. I got rid of the denominator. This much is going to be so much better. Question.
Why is it 2x plus 1 on that side?
You added a second.
Oh, yes. Good question. Shouldn't be. I'm glad somebody asked me that after going through the process, right? Thanks. I think I got carried away with the too many twos. Okay, it should be x plus 1. Thank you. Appreciate that. Okay, we got to cancel this one too, right? I'm so glad like people are paying attention. Okay, good. So that looks much better, much better. Now, go ahead and clean it up. I'll clean it up too. Let's see what kind of answer we get. Okay, so this is what I got. 3x plus 3 minus 4x squared equals to negative 4x squared minus 4x. Okay. Okay, I see some x squares in here. This is negative 4x squared, negative 4x squared, and then another negative 4x squared there. If I bring this to the other side, they cancel each other out. So they're really gone, right? Do you think we're going to have a quadratic? Not anymore, right? So this becomes just 3x plus 3 equals to negative 4x. Okay, so this is going to be a one variable equation, and linear equation. So we bring this to the other side, and then negative 3. So that's going to be 7x equals to negative 3 divided by 7. So x equals to negative 3/7, whatever that is. Is that good? Now we look at this, negative 3/7, and I check up here, is negative 3/7 part of the non-permissible value? No, it's not the non-permissible value, so therefore, this is our solution.
What happens if it's a part of the non-permissible value?
Oh, we're gonna see something like that, yeah. If it's part of the non-permissible value,
Yeah.
then that means no solution. Yeah, we're gonna see something similar. Okay, good. You're comfortable with negative 3/7? Last two examples, let's see. Oh yeah, very good. It's a slow start, but then. Okay, next one. How do we start this? MPV, okay, good. I forgot to tell you something. To figure out the lowest common denominator, we need to make sure that everything is in factored form, like the denominator is in factored form. Okay? Is there anything here that can be factored? 2x minus 2? Yes? So if we factor this out, this becomes x over x minus 1 minus 2x is equals to x plus 1 over, there's a GCF, greatest common factor of 2, so we factor that out, x minus 1. Okay. Now, question is, what's a non-permissible value? X cannot equal to 1. Okay. Anything else? That's it, right? Okay, good. That's a non-permissible value. What's the lowest common denominator? 2 times x minus 1. I want to keep it as factored form, okay, so that it's easy to cancel later. Okay, so if that's the case, I'm going to multiply both sides of the equation by the LCD. So let's do just that. Okay. I'm going to apply the distributive property of multiplication. So I'm going to multiply each term by 2 times x minus 1. So let's start with this one. Anything, if I multiply this with this part, what happens? X minus 1 cancels with that x minus 1. What's left over? 2x. Okay, so just 2x. If I multiply 2 times x minus 1 with this part, nothing cancels, right? So it's going to be negative 2x times 2 times x minus 1 equals, okay? So if I multiply the other side by 2 times x minus 1, the 2's cancel. The x minus 1 also cancels. What's left over? It's x plus 1. This is so much easier without the denominator. Denominator makes things life a little bit more complicated. Let's get rid of the complications and then it's easier to solve. Now go ahead and clean it up. I'm sure everybody knows how to do that. Okay, just by kind of scanning this equation, I don't think the x squares are going to cancel out. We're going to end up with a quadratic equation, right? So let's put everything on one side of the equation. So if you feel like you can go ahead and solve that thing, go ahead and solve that thing. Well, did you get 4x squared minus 5x minus 1? Plus 1. Plus 1. Did you get that one? Is this factorable? It's going to be 2x How do we factor this thing again? You go 4x squared minus 5x plus 1. No common factor, so you multiply these two, so that's going to be 4x squared. 4x squared, factors of that will give us negative 5x, so it's going to be negative 4, negative 1. Four x is a common 4x is a common factor, so it's x minus 1. Negative 1 is a common factor, it's going to be x minus 1, so it's going to be 4x minus 1, x minus 1. Oh, which one? This piece?
Yeah.
This piece? Okay. So what happened here? Okay. So what happened here? So I'm just gonna, there's a question over there. What happened to this 2? We lost it. Okay. This is 2x minus 4x squared plus 4x equals x plus 1. Put that aside. So this is now becomes negative 4x squared plus 6x equals 2x plus 1, yes? Yeah, okay. Now I'm going to put everything on the other side. So this becomes 4x squared minus 6x plus x plus 1. You see, we already lost the 2. And then these two can be combined. They're like terms. 4x squared minus 5x plus 1. Yeah, better? Good. Okay, so having said that, what happens? What's the,
We're just saying,
well, you say hi to you too.
this is my boss everywhere.
Oh.
Chris Rose.
Yeah.
We all have a boss.
Yeah.
And then that means by default, my boss. Okay,
Enjoy your class learning.
thanks. Okay, so over here, what's the solution?
Why is it so blurry?
I don't know.
X equals 1 over 4.
X is equal to 1/4. And then this one here, x equals to 1. Okay, good. It looks like we have 2 solutions. Look at that. Is that true?
No, we have to.
Okay. Well, according to the non-permissible values, x cannot equal to 1. But the solution here, x equals to 1. So this one here is, what do we call this one again? Extraneous solution. Okay. So what's our only solution? 1/4. So therefore, the solution is x equals to 1/4. Isn't this fun? Pretty cool? You like it? Enjoying it? Last one. We made it to the last one. And then you're gonna go to the learning mode. Maximize the error. Okay, here we go. LCD. Oh, no. What can we do first?
Factor.
Factor. Let's go ahead and factor that thing. Okay, so what's the non-PV? Can somebody give me one? 0. Okay. Oh, and X cannot equal to 1. Is everybody okay with that piece? Yeah? Okay, X cannot be 0, X can be 1. Okay, now we can do LCD. What's the LCD?
X times X minus 1?
So X times X minus 1. Is everybody getting better with this one? Lowest common denominator, you scan the denominator, what are the factors? X, I see X, so I write it down. I see X minus 1, I write it down. So that's it. Okay, so let's go ahead and multiply by LCD on both sides. So if we multiply by LCD, some factors will cancel. So the very first one, the X will cancel. So if the X cancels, what's left over? You got X minus 1 times X minus 1, right? Equals. Okay, now we're going to do the distributive property of multiplication. If I multiply the LCD by the first term, what would that be? The X minus 1 will cancel. So it looks like we only have X. You okay with that? Just the X? Okay. Minus. If I multiply by LCD, oh, it looks like everything cancels. The X cancels, the X minus 1 cancels. What's left over? Just minus 1. Okay. That's good. Is everybody okay with that piece? So the X will cancel that X. X minus 1 will cancel that. We'll just... Okay, this one we're gonna definitely end up with a quadratic equation because if we expand that, what does it expand to? X squared minus 2x plus 1 equals to X minus 1. Okay. Everyone's okay with this, right? Good. Bring everything on one side of the equation. Good. You think it's factorable? Yeah? So it's X minus 2, X minus 1 equals to 0. So that means X better be 2 or X equals to 1. And we check, hey. Well, the solution says X equals to 1, but 1 is our non-permissible value. Cross that off. So this is going to be our extraneous solution. So that's not part of our solution, right? So our only solution in this case is, therefore, the solution is X equals to 2. Yes? Good. Okay, so that concludes our solving of equation. So we'll give you we'll pause for about 5 minutes, get a little bit of a stretch. And then when you get back, I'm going to show you some Desmos stuff. Okay. If we were to graph this, where would the point of intersection be? Okay. So yeah, go ahead, take a quick break, and then we'll see you in 5 minutes.